Well, today I'm going to take a class on O-level chemistry. Today's topic will be electrolysis. We'll know that electrolysis is a very important chapter. Okay, let me start with the first slide. Well, to understand about electrolysis, first we need to understand ionic compounds. Ionic compounds always formed by the strong electrostatic attraction force of positive ions and negative ions. Well, like sodium chloride, it is an ionic compound, and here sodium ion and chloride ion will have very strong electrostatic attraction force. That is why they are held together very close with great force, and that is why the melting point of ionic compounds are very high. And in the normal state, ionic compounds are solid. Their ions cannot move from their position. Okay. In our daily life, we know that metals are used to conduct the electricity, as metals have delocalized free electrons, and those free electrons will help to conduct the electricity. But there is another type of substance which can also conduct electricity. Those are ionic compounds. Here the ions are able to conduct electricity, but not in the normal state, because in the normal state, as I have already mentioned, the ionic compounds, in ionic compounds, the ions cannot move. Without the movement of the ions, it is not possible to conduct electricity by any substance. But when the ionic compounds will be melted or they will be dissolved in aqueous solution, then the ions will split, they can move, and in that state they can conduct electricity by some chemical changes. This process is actually electrolysis, by which the ionic compounds can conduct electricity in molten or aqueous condition through some chemical changes. As the ionic compounds conduct electricity in molten or aqueous state, so these are called electrolyte. Well, we know that when an ionic compound is formed, metals will always transform into positive charge as they tend to lose the electron. Here the example is given like aluminium. Aluminium is group 3 element, so it has three outermost electron. When it will form bond with a non-metal like chlorine or any other non-metals, then these 3 electrons will be lost. So it will be transformed into positive charge. On the other hand, the non-metal have the tendency of gaining electrons. So they will be transformed into negative charge. So we can understand that the ionic compound contains positively charged metal and negatively charged non-metals. Well, now, what are the uses of electrolysis? Electrolysis has many uses. Well, for example, from this slide we can see that metals can be extracted by using electrolysis process. Some very important chemicals like chlorine, bleaching powder, sodium hydroxide can be made by electrolysis process. Then purification of metal like copper can be also done by electrolysis. Electroplating is a very important process by which we can give a coat of a very precious metal on a poor metal. So there are many uses of electrolysis. Well, now let me explain the electrolysis process using molten ionic compound. Here I'm going to use molten lead bromide. Lead bromide is an ionic compound that we can understand as it contains lead metal and bromine non-metal. Okay. Well, lead bromide is transferred to a vessel. Here we have used two electrodes. These, one of the electrode will be connected with the positive end of the electric source, that is called anode. Another electrode is connected with the negative end of the electric source, that is called cathode. A bulb is also connected with in series with this circuit. Well, we can see that solid lead bromide is used here. So let's check what happens if we turn on the switch. That means if we give the potential to the two different electrodes. As solid lead bromide is used, so ions are not able to move here. So as they cannot move, so it is not possible for lead bromide to conduct electricity. The circuit remains incomplete. As a result, the bulb will not glow. Now, once if we melt that lead bromide by using a Bunsen burner at 330 degrees Celsius temperature, it will be melted. So here we are using molten lead bromide. Now let's see what's happened if we turn on the switch. We can see this time the light glows. That means the circuit is completed here. That means molten lead bromide is conducting electricity here. And chemical changes happens. That is why we can see that reddish brown gas is formed at anode. That why what gas is formed, that chemistry will learn in my later slides. Here this thing happens. Solid lead bromide, when it will be melted, then the ions will split from each other and then it will move, the ions will move. That is why it is capable of conducting electricity. That is why the circuit has been completed. We will see another gray metals will form at cathode. That gray metal, that is lead. Now let's see the chemistry of this electrolysis. What chemical change happens in this electrolysis process? Let's see it. Well, we have used lead bromide as electrolyte. Molten lead bromide contain two different ions, lead 2 plus and bromine minus, these two ions. So when the current will be passed through it, then two different electrodes will attract two different ions from the molten solution. First at cathode. Cathode, that means the negative electrode. Negative electrode will attract the positive ion. Here the positive ion is, anode is positive ion. So this positive electrode, so this positive electrode will attract the negative ion, like bromide ion. So bromide ion will migrate towards the anode, and as anode is positive end of the electric source, so it has anode has deficiency of electron, and on the other hand, bromide ion has an extra electron. So bromide ion will lose this electron, and that equation can be shown in this way. When electrons will be lost, that is called oxidation reaction. We must have to remember that anodic reaction is always oxidation reaction. But we know that bromine is diatomic. All halogens are diatomic. So here two bromide ion will be used, will be shown, where two electrons will be lost and a diatomic bromine will form at anode. Due to the presence, as bromine gas is produced at anodes, that is why we see reddish brown color at anode. Now let's see what happens at cathode. In cathode is connected with the negative end of the electric source. So that means there are available electrons at anode. So it will attract the positive ion, which has deficiency of electron. Here the positive ion is Lead2 plus. So it will be attracted towards the cathode. As Lead2 plus has deficiency of electron, so it will gain 2 electron from cathode, and then it will be transformed into lead metal. That is why we see gray lead metal is produced at cathode. So as electrons are gained, so here in cathode, reduction reactions occur. We have to remember that cathodic reaction is always reduction reaction. Well, now we have already discussed how the electrolysis process is conducted when molten electrolyte is used. There is another condition. The ion of the ionic compounds will split, and then it will be able to conduct electricity. That is, if the ionic compounds are dissolved in water, then the ions will be split, and then it will be able to conduct electricity. Here we will use aqueous solution of sodium chloride, that means table salt, to see what electrolysis happens here. Well, first we want to use the solid sodium chloride. The circuit will be completed like the previous procedure. Let me turn on the switch now. We can see that solid sodium chloride ionic compound, which has very strong attraction between the opposite ions. The opposite ions cannot move. That is why it is unable to conduct electricity. That is why the light is not glowing here. Now let's see what's happened if we dissolve this sodium chloride in water. We can use a stirrer to make sure that ionic compound is completely dissolved in water. Now we can complete the circuit using two electrodes and a bulb. Now let me turn on the switch and let's see what's happened. Now this time you can see that light glows. That means now the aqueous solution of sodium chloride is conducting electricity. That is why the light is glowing. And we can see another observation at anode, a yellowish green type gas is produced. In the solution, as the ionic compound is dissolved in water, so the ions are moving. We can see it from this slide. And that is why, as the ions are moving, so that is why it is capable to conduct electricity. Cathode will make hydrogen gas and anode will make chlorine gas. We know that chlorine gas color is yellowish green type. And in the solution, we will see, if we test it by using a litmus paper, we will see that the red litmus paper will turn blue and the aqueous solution contains sodium hydroxide. Now what chemistry happens in this electrolysis process? While we will discuss about the electrolysis of aqueous solution of any ionic compound, then we have to consider these three factors: electrochemical series, that is reactivity series, then concentration of the solution, and also type of electrode. In most cases, we use graphite electrode as it is inert and non-biased. And due to the different condition, we will see different reaction will happen at excuse me, at anode and cathode. And also electrochemical series is important to understand the electrolysis process of aqueous solution of electrolysis. We'll understand the use of this concept in our later slides. Well, we are going to use concentrated solution of sodium chloride. That means the solution can be two types. One is concentrated and another one is dilute. When concentrated sodium chloride will be used, then we can understand the amount of sodium ion and chloride ion will be more in the solution. So let us consider which ions are present in the solution. So from sodium chloride, we will get sodium ion and chloride ion. Water, as the sodium chloride is dissolved in water, so water will also split to give H plus and OH minus. Excuse me. At anode. At anode, anode is connected with the positive end of the electric source. That means it will attract the negative ions. Two negative ions are available in the solution, chloride and hydroxide. Both the negative ion will migrate towards anode. Now the question is, which one will be discharged? Well, here the chloride ion will be discharged. We are using concentrated solution of sodium chloride. So in the solution, the amount of chloride ion is more. So due to the more amount of chloride ion in the solution, chloride ion will be discharged instead of hydroxide. So we can see the oxidation reaction here. From two chloride ion, 2 electrons will be lost and we'll get a chlorine molecule. And that is why we see yellowish green gas is produced at anode, that is chlorine. Now let's see what happens at cathode. Cathode, this electrode is connected with the negative end of the electric source. So it will attract the positive ion. Two positive ion, H plus and Na plus, will migrate towards cathode. Now in this case, we have to consider the reactivity series. In the reactivity series, H plus is much below than Na plus. The one which is below in the reactivity series, that one can gain electron more easily. Gaining electron will be easier for that one which is below in the reactivity series. We know that H plus is below Na plus in the reactivity series. So instead of Na plus, H plus will be discharged here. So you can see the reduction reaction. 2H plus ion will gain 2 electron to produce hydrogen gas. Well, now let's see some quiz questions. Not exactly quiz, to understand. Once we understand the electrolysis process, we should be able to answer this question. There are two options: conducts and does not conduct. So you have to find out copper sulfate solution, can it conduct electricity in electrolysis process? Yes, because copper sulfate is an ionic compound and its solution, copper sulfate will be dissolved and the ions will split, so it is able to conduct electricity. Solid lead bromide. Lead bromide is an ionic compound, but in the solid state, the ions are not able to move. So it does not conduct electrolysis. Molten aluminum oxide, in molten form also the ions will split, so it can conduct electricity. Solid copper sulfate is ionic compound, but in the solid form, the ions are not able to move, so it does not conduct electricity. Molten lead bromide, in molten form, lead bromide can conduct electricity. Sodium chloride crystal, that means it is not, neither it is dissolved in water nor it is in the molten form, so it does not conduct electricity. Sodium chloride solution, in the solution form, it can conduct electricity. So let's check the answer. All are correct. Well, that's all for today's discussion. Today I've discussed about electrolysis process, which is included in Cambridge O-level syllabus. I hope you have understood, and thank you very much for today.